Well, hello everybody. Thanks for coming. So today I want to, that was cheesy. Today I want to talk about practicing Punnett squares with monohybrid crosses. Remember from the last video, if you watched the video right before this, if you're watching them in order, like you should be, then last video we talked about monohybrid crosses where you're just comparing one trait. And so I want to do some practice problems using Punnett squares with you right now. So there's 3 questions that I want to go over. And each one gives you a different amount of information and you have to figure out how to solve the problem. Okay, so let's start with the first one. The question says, in cattle, the allele for cloven hooves, capital H, is dominant over the allele for mule-footed hooves, lowercase h. Okay. The phenotype is shown. That's the phenotype, the physical appearance, remember. The question is, what is the probability of cloven hooves in the offspring of parents that are heterozygous for the trait? So we want to find out what the percent chance is that the offspring will be born with cloven hooves if both parents are heterozygous. If you will recall, heterozygous means that the genotype is different. The 2 alleles are not the same. They're different. That's what hetero means, different. So that means that mom is going to be big H, little h, and dad is also going to be big H, little h, because both parents are heterozygous, okay? So big H is cloven, little h is mule. Okay, both parents are big H, little h. What's the percent chance that their kids will have cloven hooves? Well, let's use a Punnett square to find out. So once again, mom and dad are both big H, little h. Let's say that's mom and that's dad. So we make our square, the Punnett square, and then we just work it like a times table, okay? Don't forget, big H is cloven, little h is mule. Okay. So this square is big H, big H, little h, big H, little h. Remember, always write the capital first, and then little h, little h. Okay. So there is well, I already know what it's going to be. So let me back up. I was about to say what the answer is going to be. Let me walk you through why the answer is what it is. All right, so remember, these are the possible genotypes that the kids could have, the offspring could have. The possibilities here are big H, the kids could be big H, little h, or they could be little h, little h. Now, what's the percent chance? Well, of big H, well, how many squares? There's 4 squares, and only one of them has big H. So there's a 1 in 4 chance, which is 25%, that it'll be big H. What about big H, little h? There's 2 out of the 4, so that's a 50% chance. Little h, there's a 1 out of 4 chance. Okay. But the question was, what's the percent chance that the kids are going to have cloven hooves? Well, remember, all you need, if cloven hooves are dominant, you only need 1 capital H to be cloven, to have cloven hooves. You only need 1 because remember, when the dominant is present, it always gets expressed. So any of these genotypes that have a capital H in them are going to result in cloven hooves. So all these kids, if it's big H, they'll have cloven hooves, and if they're big H, little h, they'll also have cloven hooves. So add these two together, 25 plus 50, that is a 75% chance that the offspring will have cloven hooves. So the answer to that one is C, 75%. Okay? Okay, so here's another one. It says chickens can have different types of feathers, frizzled or straight. Assume that frizzled is dominant over straight, okay? So let's say that capital F is the dominant one, and that's frizzled feathers. Lowercase f is straight feathers. So to cross between two chickens with straight feathers, so mom and dad both have straight feathers, what percentage of the offspring can be expected to have frizzled feathers? Well, remember, the only way that you can have a chicken with straight feathers is if there's no dominant frizzle feather allele. So therefore, you can conclude that both parents, both mom and dad, since they both have straight feathers, their genotypes must be little f for mom and little f for dad. So what's the percent chance that the offspring can be expected to have frizzled feathers? Well, 0. Because neither mom or dad have a capital F. So I don't even need to do a Punnett square in this. I could, and I could show you, but they would all be lowercase f. They'd all be recessive, okay? But there's no need to even do a Punnett square on this one because there's not even the possibility to have frizzled feathers because there's no capital F in either parent. So there can't be a capital F in any of the kids because neither one of the parents have it. So the answer to that one is 0%. There's no chance that the kids could have straight feathers. One more. I gotta scroll down here. Okay, last one. Okay, so in cattle, the allele for shorthorns, S, is dominant. So capital S is short. And lowercase s is long. So 2 shorthorn cows are bred and produce 4 offspring. 3 have shorthorns and 1 has longhorns. What are the most likely genotypes of the parents? Okay, so now they're doing it backwards. They're giving you the genotypes or the phenotypes of the kids, and they're asking you to go backwards and find out what the parents must be. Okay, so before they gave us the parents and we had to figure out what the kids were. Here, it's the opposite. So 3 have shorthorns and 1 has longhorns. Okay, so in order to have longhorns, one must be, you have to be SS. That's the only way that any of the kids could have long. So at least, one of the 4 kids has longhorns. So one of the 4 kids is SS. Now the other 3 are going to be either SS or big S or big S little s. I know it's hard to tell the difference. That is a little s, okay? So that's going to be the other 2 kids. Well, we know that the only way that the kids can have, you can have one longhorn kid is if at least one of the parents has a little s, okay? But on this one, let's just go through the answer choices and we'll mark out the ones that we know aren't right, okay? So what are the most likely genotypes of the parents? If it's big S, and little s, let's see. Let's test that one out, okay? Let's do a Punnett square where one parent is this and the other parent's that. So we had big S and little s, Make our Punnett square here. This one is, well, it's really hard to see. Let me make these even smaller. Okay. So we got big S, big S, little s, big S, and big S, little s. Okay. So all 4 kids are going to have short horns in this case. So we can't be that one. We know that that's not it. So it's not A. What about big S, and big S, little s? Well, let's find out. Big S, and big S, little s. Okay. So we've got big S, big S, little s, big S, little s, and little s, little s. Okay. Well, look what we got now. We got 1, 2, 3 kids who have short horns, and 1 that has long horns. So that fits the bill. It must be B. All right. So we answered 3 questions here, and in each of the 3 questions we had a little bit different information. In one, we had the kids. They asked us to find out what the parents were. In the other, we had parents asked us to find out what the kids were. So that is it. Now, in the next video, we'll do dihybrid crosses where we're actually comparing 2 traits. So we'll compare like short horns and brown fur instead of just one or the other. And that's called a dihybrid cross, and we'll do that next time.